Hi, it's Mrs. Moret with a little tutorial over tonight's homework. This is Unit 2, Lesson 11, Practice Problems. So, Lesson 11 was about finding solutions to equations of polynomials and also points of intersection between polynomials. So there were two strategies addressed in class. One was to solve algebraically, and the other was to solve by graphing. So number one is a good problem to solve algebraically. And so I'm going to set that one up in the space under number 2, that open space. So what are the points of intersection between these graphs? F of x equals x squared times x plus 1, and g of x equals x plus 1. Well, when the question asks for points of intersection, it's important to remember that a point contains both an x value and a y value. So when I solve this algebraically, I'm going to have to solve for both of those variables. So to start out, I'm going to set the x squared times x plus 1 from f of x, x squared times x plus 1. I'm going to set that equal to x plus 1 from g of x. And so since both of these equations have this factor x plus 1, I'm actually going to subtract it from both sides of the equation so that the right side is equal to 0. And so I'm going to rewrite x squared times x plus 1. And then minus this x plus 1 is equal to 0. So again, overall, this equation is just showing like two big terms. That's one and that's the other one. And so since both terms contain the entire factor x plus 1, we can factor it out. It goes in parentheses out in the front. And then the first term, if I factor out the x plus 1, I just have x squared. And then the minus comes down. And if I factor out the x plus 1 here, I need a 1 like a placeholder, equals 0. So this polynomial is in factored form. The factors are all the way simplified. And so I'm ready to set each factor equal to 0 and solve for x. So x plus 1 equals 0. Subtract the 1, and I get the solution, x equals negative 1. I'm going to put that here, negative 1, comma, and kind of a space there. I'm going to figure out the y value in just a minute. And then for the second factor, x squared minus 1, I'm going to write out x squared minus 1 equals 0. I'm going to add the 1 over, so I get x squared equals 1. And then to solve for x, it's just the positive and negative square root of 1, which means positive or negative 1. Well, I already have negative 1 from the first factor, so I don't need to repeat it, but I do need a second solution where x is a positive 1. Now I'm going to take each of those values for x, the negative 1 and the 1, and plug them into either equation because at this point, the two are equal. If they are equal, then if I put a negative 1 in for x, I should get the same answer for both of them. And likewise, if I put a positive 1 in for x, I should get the same answer for both of them. And so I truly believe that g of x is the better choice in this situation because I just have to add 1. So if I put negative 1 here for x, I get negative 1 plus 1, which is 0. So negative 1, 0 is 1 point of intersection. And then same thing, put the positive 1 here for x. 1 plus 1 is 2. So 1, 2 is the second point of intersection, and those are the two solutions for problem 1. For problems 2 and 3, I actually chose to graph on Desmos to find those solutions. So here's the graph. So here's f of x and g of x on number 2, and I'm supposed to find their points of intersection. So I just graphed them. And Desmos has this really cool function where if you just touch the graph twice at a point where they appear to cross, then it will show you the solutions. So number 2, the solutions are 2, 0, and 4, 18. So as long as you have correctly, put these equations into Desmos, you should not have a problem finding that answer. So for number 2, it was 2, 0, which is D, and 4, 18, which is E. Number 3, I also put into Desmos, x minus 3 times x plus 5 equals negative 15. If it was equal to 0, it would be really easy to solve using the factors. But because it's equal to negative 15, it's not so easy to solve algebraically. There's a lot of steps. And so I put it into Desmos instead. So I'll turn that off. So the left side of the equation I graphed as y equals x minus 3 times x plus 5. And then the right side of the equation I graphed as y equals negative 15. And so here on the graph, I can see, oh, they cross right here and they cross right here. So this time it just gave me an equation. It didn't refer to functions or points of intersection. It just asked for solutions to the equations. So since the equation only used x, the solutions are just the x values from this point. So the values of x that make y equal to negative 15 are negative 2 and 0. Okay, so the solutions for problem number 3, x equals negative 2 and 0. All right, problem number 4. What are the x-intercepts of the graph of y equals 5x plus 7 times 2x minus 1 times x minus 4? So remembering x-intercepts are the value of x that makes the equation equal 0. And since this is in factored form, if any of these factors are equal to 0, then the equation is equal to 0. So we basically have 3 little equations to solve. And you might have noticed that there's like major typos going on here, but it's correct on your textbook has some fractions. I'm not sure. The formatting didn't carry over to this document, but that's okay. So I'm going to set each factor equal to 0 and solve for x. So 5x plus 7 equals 0. I'll solve that by first subtracting the 7 from both sides. So that's 0 there. 5x equals negative 7. And dividing both sides by 5, x equals negative 7/5. So that's one solution, or one of the x-intercepts, I should say. The next one, 2x minus 1 equals 0. I'm going to solve this by adding the 1 to both sides. If I do it on the left, I have to do the same exact thing on the right. This gives me 0 there. So 2x equals 1. And then divide both sides by the 2 to get x by itself. X is equal to 1/2. So I've got 2 of the x-intercepts, negative 7/5, positive 1/2. And then I'm going to find the third one by solving x minus 4 equals 0. And that's a simple one. I'm just going to add the 4 to both sides to get the x by itself. And x equals 4. Okay, so the 3 intercepts are x equals negative 7/5, x equals 1/2, and x equals 4. So from your textbook, that is solution C. Number 5 says, which polynomial function's graph is shown here? So if I want to be able to look at what the equation for this graph would look like, I'm going to focus on the zeros. I see there's zeros at -2, +1, and +4. Side note, I also noticed that the function goes straight through in those places. So each of those zeros has a multiplicity of just 1. If it was 2, we would see a bounce, and if it was 3, we would see a little twist like an opened up paperclip, and I don't see that at any of those spots. So each has a multiplicity of 1. So from the 0 of -2, I know it came from a factor of x plus 2. And then from the 0 of +1, that comes from a factor of x minus 1. And the 0 of +4, that comes from a factor of x minus 4. So if I put an f of x in front of this and equals, then I have the equation of the polynomial whose graph is shown. So looking at the answer choices, this has +1, +2, +4, that's not it. +1, -2, +4, that's not it. Didn't reverse the signs between the zeros and the factors. I believe the next one is the correct answer, -1, +2, and -4. Okay, so it's answer choice C. We've got 2 more problems. One is a graphing problem. We're going to sketch the graph of g of x equals -x² times x plus 2. So there's a few things I need to know. I need to know the zeros. I need to know the end behavior. And then typically we would also want to find the y-intercept. So for the zeros, I would say because of this factor, the x squared, one of the zeros is 0. And from the x plus 2, that gives me a 0 of -2. And just kind of note that this one is going to be a double, and so it's going to bounce there. All right, so those are the x-intercepts, the horizontal intercepts. I'm going to put those on the graph first. Sketch in this little place here. And so a point at 0, so the origin, and then also at -2. And I know that my point at the origin is going to have a little bounce. So I'm going to make a little b next to it just to remind myself. Okay, so I said we needed the intercepts, the x-intercepts are horizontal. We also need the y-intercept, which this time is also going to be 0. But just as a side note, you find the y-intercepts by plugging 0 in for x and then finding the answer. So if I plug a 0 in for x to the equation, a -0 squared times 0 plus 2, well, we're just multiplying by 0. So that tells me that the y-intercept is 0, and that's obvious since there's a point at the origin. All right, next is the end behavior. Well, to determine the end behavior, we need to know the degree. Is it even or odd? So the degree of a polynomial in factored form is the sum of the degrees of all of its factors. So this factor has a degree of 2. This factor has a degree of 1. So the overall degree of the entire polynomial is 2 plus 1 or 3. So the degree is equal to 3. 3 is an odd number, and the polynomial is negative. So we are looking for odd, negative, and behavior. So odd, negative, overall, looks like this. As x gets larger in the negative direction, y gets larger in the positive direction. As x gets larger in the positive direction, y gets larger in the negative direction. So that's what the end behavior is going to look like on this polynomial. So from the 0 of -2, that's the one furthest to the left. So the polynomial will go up from there. It passes through since -2 is a single 0. And then it loops back up to bounce at 0 and then continue going down from there. All right, so that is a rough sketch of g of x equals -x squared times x plus 2. And then finally, problem number 7. The graph of a polynomial function f is shown. So 2 questions. Is the degree of the polynomial odd or even? Explain how you know. And what is the constant term of the polynomial? So remembering back, odd polynomials have opposite behavior at each end. So they either go this way or they go this way. That's odd. Even polynomials, oops. Okay. Even polynomials have the same end behavior on each side. So it's either both ends are heading up or both ends are heading down. So I see they're both heading down, which means this is even. Number 2, what is the constant term? We can tell the constant term by finding the y-intercept. Okay, the y-intercept is right here on the graph at -4. So the constant term is -4. All right, that's the end of your assignment, and I hope this was helpful.